Good morning and welcome to Miss Letter's Calculation Station where things add up. Today we will be doing 9.1 Simplifying Radicals. Now it's very important that you guys have out your notebooks and you are following along. Please feel free to email me and contact me to find out anything that you are having problems with. So 9.1 Simplifying radicals. So the first question is how do you know if a radical is simplified? How do you know? How do you know if a radical, and this is the radical, it's also called the square root, is simplified? So there's three ways. The first way is that there's no perfect squares under the radical. There are no perfect squares. There's no perfect square factors under the radical. The other way is that there's no fractions under the radical. There are no fractions. Oops, I think I left my whiteout at work. So this is going to be fun. So there's no fractions under the radical. Squeeze an S in there. And there's no radical in the denominator. There's no radical in the denominator. All right, so when we're simplifying it, a lot of times we just want to use our calculator and say, oh, the square root of 320 is this irrational number. Well, that's some rounding because the number actually, the decimal keeps going and going. So when we're simplifying it, we want to have an exact. So let's look at the square root of 320. So there's a couple of rules on here. And the first one is that you can only use prime numbers. And we know what prime numbers are because we did our prime number warm up earlier. If you have not done so, please go to Canvas and do that. So you want to use only prime numbers unless it's a perfect square. Unless it's a perfect square, like 25. 5 times 5 is 25. 6 times 6 is 36. So 25, 36, 49, all of those. Those are perfect squares. The other rule, and this is going to make sense in just a minute, a lot of times we don't know when to stop. So this is when we're going to stop. There's two ways that you can stop. You're going to either stop at a prime number or stop at 1. So when you get down to 1, you can stop. So this is what it looks like. We're going to do downward stacking. It's kind of modified the factor tree. So the difference between this and the factor tree, other than the way it looks, is that you can only use prime numbers. I always start with the easiest one. 2, I can always half things. If I have a problem, it's like upside down division. So I have 320.